Hello everyone. Today I will derive field due to infinitely long, uniformly charged straight wire. So this is a straight wire which has a positive charge on top of it. To derive the expression for electric field due to this wire, we will use Gaussian surface Gaussian surface concept. Okay. So for Gaussian surface, what do we have to do is we have to consider a uniform surface around the wire which will enclose properly the wire. So I am taking a cylindrical Gaussian surface because the suitable Gaussian surface for the wire is cylinder, not a cube, neither a sphere. Okay. So over this Gaussian surface, we will apply Gauss's law. Okay. And everybody knows what is Gauss's law. I am just telling you once. Gauss's law says that the electric flux coming out of any surface is equal to Q by epsilon naught. This is the Gauss's law. Okay, the electric flux is equal to charge enclosed within the surface and by divided by epsilon naught, where phi is the electric flux. Okay, phi e. What is the charge? Q. It is charge enclosed within the surface. And what is epsilon naught? It is the permittivity of the medium within which we are working. So this is the Gauss's law. Now we will find phi using basic definition. So by basic definition, what is phi? Phi is nothing but sigma E del S. This is the basic formula, the product of the electric field intensity to the total surface area. Okay, what is E? E is, let me write it here, E is the electric field intensity. Okay, and what is del S? Del S is the area over which we are calculating the flux. Okay, so by basic rule, if we see, so there are three surfaces, correct? This is the top surface for the Gaussian surface. This is top, this is bottom, and this is the all around it because it's a 3D cylinder all around it. So there will be three flux coming out of it. So first top surface is suppose phi 1. Okay, the middle surface flux is suppose phi 2, and the bottom surface flux coming out is phi 3. So there are three flux coming out of it. Okay, so we know by rule the electric field lines, they come out, let me draw, from positive charge. So they will come out like this, positive charge outward. The electric field lines or flux is always outward, perpendicular to the wire, and they are outward. So you can see there is no flux upward and in downward direction. You can see here there is no flux on top, and there is no flux here. There is flux only all around the cylinder. Suppose this is cylinder. So all around the cylinder here is the flux. On top it is 0 and down it is 0. Okay. So all around the wire the flux is coming out. So can I say, if you see carefully, can I say phi 1 is 0 because there is no flux coming upward, and phi 3 is also 0 because no flux coming downward. So what is phi 2? Phi 2 is nothing but E sigma E del of S, correct? So E we don't know, the electric field, sigma of del S. What is sigma del S? Sigma means entire, and del S means the area over which we are finding the flux. The total area of this side one. Okay, we are not taking top, we are not taking down. For phi 2, we are taking only all around the cylinder. Curved surface area. This one is curved surface area. So it will be E into 2 pi RL. Okay. I have taken the length of the wire is L and the distance at which we are observing is R. From the center of the wire, the distance is R. Length of the wire enclosed by the cylinder is L. Okay. So R is the radius of the cylinder and L is the length of the cylinder. So this is phi 2. So what is phi net? If I calculate, phi net is phi 1 plus phi 2 plus phi 3. So phi 1 and phi 3 is 0. So this is 0 plus 2 pi RL into E, which is this one, plus 0. So it is 2 pi RL into E. This E. So we got flux by two formulas. One formula was Gauss's law and one formula is the general rule, right? General definition. So this one is the flux due to Gauss's law and this one is the flux by basic definition. So can I say 1 is equal to 2? Correct? Here I am saying 1 is equal to, so I can say Q by epsilon naught is E into 2 pi RL. Okay, we are interested to find the electric field. So what will be E? E will be, this will go here. Okay, so it is Q by epsilon naught 2 pi RL. What is Q by L? Charge per unit length for a given wire. What is Q by L? Charge per unit length is nothing but lambda, which is known as charge density. Okay, charge per unit length. So Q by L is lambda. So let me write down E is equal to lambda by, what is this? 2 pi epsilon naught R. Because see, Q by L, I have written lambda. So this is lambda. So this is the formula for electric field intensity due to the wire. And what is lambda here? Lambda is the linear, let me call it linear charge density. Okay, which is nothing but Coulomb per meter, charge per unit length. The final formula for electric field due to a wire is this. This is an important formula where lambda is the linear charge density. So clearly we can see that E is proportional to 1 by R. Okay, inversely proportional to R, you can say. So electric field due to a wire is inversely proportional to R. If we want to draw a graph, you can draw E versus R. So what will happen as we go away from the wire, the E will start to reduce. So it will go down like this as we go far. So this is the graph E versus R. Okay. So please memorize this formula, the electric field due to the long wire. See you in next video. Bye everyone.